In this video, I'll describe the Run Simple Program assignment as part of this week's homework. For this assignment, we're going to be given a program such as this program right here in a language that's pretty similar to a assembly language program, but it's a very restricted form. And what you're going to do is write a function, runSimpleProgram, that takes a program such as this and some inputs or arguments and runs this program on these inputs. And your function is going to return the result. All right, so what's going on inside this program? Well, to begin with, any line that starts with an exclamation is a comment and can be ignored. But this one's telling us that this program's trying to compute the max of A0 and A1. A0 and A1 are arguments. When you call your program, you hand it arguments, which must be a list of integers, and the first one is A0, the second one is A1, and so forth. Anytime that you specify an argument inside your program, it must be a capital letter A followed immediately by the integer. So this is arg0, this is arg1. Great. In addition to arguments, we can have local variables, and those will be stored in L0, L1, L2, and so forth. L meaning local variables. So we have arguments and locals. You get the argument list passed into your run simple program right there, but the local variables, you're going to have to create your own list for those. So create a list of local variables, and if a local variable, when you access it, if it hasn't already been set, it should be 0. So a line such as this is an assignment line. Assignment lines begin with a local variable, so L0, followed by an expression. If the expression was just an integer or just a value, I could do like L0, 0, and that means set L0 to 0. Here, it's set L0 to this expression. So this expression is a prefix form, so you have the operator first, and then the operands, and it means minus A0, A1 is to subtract A0 minus A1. You can also have done plus A0, A1, which would then do A0 plus A1. Prefix form takes a little getting used to, but that's what's going on here. So this line is the same as if we said L0 equals A0 minus A1. So that assigns that into L0. Fine. The next line, JMP plus, means jump if positive. And you're given a local variable or an argument or a value, in this case L0. If that value is positive, jump to this label. Somewhere inside your program there has to be a label, which is a line that starts with exactly that text. Labels always must be lowercase to start. There's our label, and it ends in a colon. So this line right here is the label. This says to jump to the label if L0 is in fact positive. Well, L0 will be positive if A0 minus A1 is positive, which means if A0 is larger than A1. So we'll get down here if A0 is bigger, and then we'll return A0. Jump positive will not jump if, in fact, L0 is not positive, which would happen when A1 is bigger, in which case we just proceed to the next line and return A1. So we can see, in fact, this works. You just store the difference of A0 and A1 in L0. If the difference is positive, that means A0 is bigger, so return it. Otherwise, return A1. So that's that program. Here's another program for you. This one sums the numbers to n, where n is provided in A0. For this one, we're going to have a counter in L0, and L1 is going to be our result. So our counter starts out at 0. Let's just look at the counter. And then we increment our counter by 1 on each loop. Okay, so that's our counter. We keep doing that so long as what? Well, we keep doing that until our counter gets to A0. It gets to A0 if the difference, but this is the difference between L0 and A0. This is L0 minus A0. We store it in L2. And if we jump on 0, which means if L2 equals 0. Up here, we jumped on positive. If L0 was positive, jump 0 means jump if L2 is 0. So if L2 is 0, we'll jump to done, and done will just return L1. And L1's carrying the result. Fine. The other command we have here is to jump to a loop, and jump without plus or 0 means jump no matter what. So let's follow the logic of this program. L0 is 0, L1 is 0. Loop. You don't do anything here. It's just a label. It's a target for some place to jump to. Set L2 to L0 minus A0. And let's say that A0 was in fact 5. Fine. So L2 is going to be 0 minus 5, negative 5. We're not done. L0 becomes L0 plus 1. Add 1 to L0. L0 is now 1. And then we add that. So this is like our counter, and we're adding our counter into our running tally here. L1 will get L1 plus L0. We jump back to our loop. Are we done? No. So then add 1 more to L0, which would make L0 to be 2 now, and add 2 into our sum. Jump to the loop. Are we done? No. Make L0 3. Add 3 into our total. Jump back to the loop, and eventually when we're done, because L0 made it all the way up to A0, so the difference that we stored in L2 is in fact 0, then we jump to done, and we return L1.